All right, so now that you have sort of the introduction, we're going to go and start with example 1. So it says, evaluate the 6 trig functions of the angle theta, and you're given this triangle. So the first thing you need to do is have all of your sides. So you need to find the missing side using Pythagorean theorem from yesterday. So you have a, b, 5 squared plus 12 squared equals c squared, 25 plus 144, which is 169, which we know is a perfect square, so c equals 13. That's also a pretty famous Pythagorean triple. All right, so this actually isn't going to be too crazy. Everything's going to be written as a fraction. So how we remember these is SOHCAHTOA. Sine is opposite and hypotenuse. So sine of theta, opposite the angle is 12 over hypotenuse, which is 13. Done. That's it. Cosine of theta. Cosine is adjacent, which is next to, over hypotenuse, so 5 over 13. Not too bad. Tangent. Opposite over adjacent. Opposite is 12 over adjacent, which is next to 5. 12 over 5. Then we have cosecant, which, like I said before, is, CSZ, which is just sine flipped, hypotenuse over opposite, so 13 over 12. Then we have secant, which is hypotenuse over adjacent, 13 over 5, the opposite of cosine. And then we have cotangent, which is adjacent over opposite, which is the opposite of tangent, so 5 over 12. Everything can be left as a fraction. Nothing needs to be changed to a decimal. All right, so example 2. If theta is an acute angle of a right triangle, and they give you the sine of theta is 4 over 7, what is the tangent of theta? All right, so first and foremost, draw a picture, because in this one it made it very easy to visually see where everything was. So we are going to draw the exact same picture with our little right angle in the corner. And then theta, because it's an acute angle, is going to be down here. So if we know that our acute angle is here, our opposite is going to be here, our hypotenuse is always going to be across from the right angle, and your adjacent is always going to be next to. So if the sine of theta is 4 over 7, again, that's opposite over hypotenuse. So 4, 7. Now we need to find b here using the Pythagorean theorem again. So 4 squared plus b squared equals 7 squared, because we have our hypotenuse, is 16 plus b squared equals 49. B squared equals 33. And we actually are going to leave it in the radical. Not dealing with decimals today, because all of these examples are fractions with radicals. All right, so now we need to know what the tangent of theta is. Well, if we have now what everything in our triangle is, the tangent is opposite over adjacent. So remember, opposite, 4 over adjacent, 4 over square root of 33. If you remember this from Algebra 1, you can't have a radical in the denominator, so you have to rationalize the denominator. Square root of 33 over square root of 33. If you plug this into your calculator on your own, the radical just washes out, and then you just leave that because they're not like terms. And the answer is B.